everybody. We're getting ready to do lesson 5.5 of Geometry 1 Math Part 1. Part 2, Part 3, email me. And for all this stuff, you can email to 5.5 using congruent triangles. We have a 32-point skill sheet here included in the classwork. And then we have a 12-point notebook taking guide. Our bell work today, teachers, this is your bell work for your students. Parallel lines, measure 1, measure 2. Find measure of angle 1 and measure of angle 2 here. Explain your reasoning. Decide whether enough information is given to show that the triangles are congruent here. If so, state the theorem or postulate you would use. Explain your reasoning there, students. Teachers, give your students 5 minutes. Okay, welcome back for our solutions to today's bell work. Here is your solution here. We have a linear pair here, so by 180 minus 57, that gives us 123 here. And then down here, measure 2 would equal 57 by the alternate interior angles theorem here. These are alternate interiors here. This is here, then this will be over here. These lines are parallel, so we can use our alternate interior angles theorem here. And then down here, no, because angle PQS and RSQ are congruent by the alternate interior angles. These are parallel. So PQS, and then RSQ would be congruent. And SQ is congruent to SQ by the reflexive property. We have this here of congruence, but the congruent angles are not included between the congruent sides, so there's not enough justification here to decide whether these triangles are congruent. We have a side and we have some angles, but it's not enough. Okay. If you know triangle ABC is congruent to DEF, ABC is congruent to triangle DEF, then you can conclude the corresponding sides are congruent as well. AB and DE, BC and EF, and then AC and DF here. Corresponding angles are congruent as well. A and D, B and E, and then C and F are congruent as well. So therefore, using corresponding parts in the diagram, line AB and CD bisect each other at M. So AB and CD bisect each other here. And prove that angle A is congruent to angle B. So angle A and angle B, we need to prove congruency there. For sketch diagram, label any congruent segments and congruent angles. We know these are congruent, and these angles are congruent. Because angle A and angle B are corresponding angles in triangle ADM and BCM, triangle ADM is congruent to BCM. To prove that angle A is congruent to angle B, because of that, angle A would be congruent to angle B. We proved that these triangles are congruent, so they must be congruent then by that fact. Okay, reasons here again. AB and CD bisect each other at M. Line segment MA is congruent to MB, so MA here is congruent to MB. Here's the hash marks. Angle AMD is congruent to BMC. These angles are congruent. Vertical angles. Line segment MD is congruent to MC, so these are congruent. Definition of a segment bisector, so these are congruent here. Triangle ADM is congruent to BCM, SAS. You can use SAS here, side, angle, side. side, angle, side here. So angle A is congruent to angle B. Corresponding parts of congruent triangles are congruent by this reasoning here. Okay, students, here is our next guided practice showing congruence in the diagram. Triangle JKL is congruent to PQR. Why can you conclude that angle K is congruent to angle Q? And then students down here, tell which triangles you need to show are congruent in order to show that angle J is congruent to angle N here. Students, give your, teachers, to give your students about 5 minutes on this. Okay, welcome back here for our solutions. Corresponding parts, congruent triangles are congruent. We're going to use that again. And then triangle JKL is congruent to NML. So that's why there. Okay, diagrams often show overlapping triangles. It is usually helpful to visualize or redraw the triangles so that they do not overlap. So we have an overlapping here. And then we could change that here. We could like shift them down like this, and then shift that down like that. Separate them. Move this over, move that over, and then redraw diagrams. So now we can see them a little bit more clearer, possibly, than they were over there. ABC and EBD overlap. Yeah, we know that. ABC and EBD do not overlap here. Okay, all right. Okay, so visualize overlapping triangles here. Sketch overlapping triangles separately. Mark all congruent angles and sides, and tell what theorem or postulate you can use to show that these two triangles are congruent to each other. Okay, so we separate them here. Sketch a triangle separately, mark any given information. So we've marked these. We got congruent angles here. We don't have any sides yet. And angle JHG. So we have two angles here that are congruent. So that was the original there. Look at the original for shared sides and shared angles or any other information you can conclude. In the original diagram, GH, oh, they did, well, did they share this? They did not, well, they did share this. GH and HG are the same side, so GH is congruent to HG. We got a side now. So these two sides are congruent. These two sides are congruent. We got two angles. I mean, is that enough to show congruency? Add congruence marks to GH in each triangle. Yeah, we did that. So now what? You can use AAS. So we got angle, side here to prove that JGH is congruent to KHG. We have angle, side here. So that proves that they're congruent. Okay. All right, got to practice, students and teachers. Teachers, give your students 5 minutes to show how they can explain how these statements here would be true. You got overlapping triangles. So these are congruent and then these are congruent here. 5 minutes. Okay, welcome back. And then for number 4, this is our reasoning here. Angle A is congruent to angle D. Angle DBC is congruent to angle ACB, so DBC is congruent to ACB, and line segment BC, we have a line segment here. So by AAS, we're going to use AAS. We're going to say that these triangles are congruent. Explain how to show that this statement AB is congruent to DC. So corresponding parts of congruent triangles would be congruent. So AB would be congruent to DC here. And then up here, for number 3, do we have a solution? Yes, we do have a solution for number 3. Then tell what postulate we use to show that the triangles are congruent. We have BC and DA are congruent. So we have BC and DA here are congruent. And angle ADB is congruent to this angle CBD. CBD is congruent. So in the original diagram, DB and line DB and line DB are the same. So they share this, and they share two angles, do they not? Well, they share more than that. So DB, and then we have triangle is congruent by the SAS. So we have side angle side here. Same thing over here, side angle side, side angle side would be the reasoning of that. These were the original conditions here, and that is what makes these congruent. And that was lesson 5.5, part 1. Part 2, part 3 available here, as well as all of your other course materials. Thank you.